So today we will discuss about the rate law. So basically, according to it states that rate of reaction is directly proportional to concentration of reactant, right? For example, we have a equation which is A makes product P. So this equation will be A rate of reaction, which is ROR, directly proportional to the concentration of A. Right? This shows basically this shows active mass, or you can say the concentration. Right? When the proportionality sign will be removed, we will get introduced by the new constant, which is rate constant. And ROR is equal to K A. Right, here K is basically the rate constant. K is a rate constant, right? Now consider that like we have to find the unit of K. What will be the unit of K? So K will be equal to rate of reaction upon concentration of A, right? And in my previous video I have discussed about the formula, like what's the basically the unit of rate of reaction, right? So here K is equal to mole dm cube second inverse upon concentration, which is mole dm cube, right? So this will get cancelled, and here we will get the value of K, which will be second inverse, right? Basically this K value varies. The value of K varies, for it will change according to the according order of reaction, like according to the order of reaction, the unit of K will change. Right. Okay, now let's look into an example of the reaction. For example, we have 2NO2, which makes the product 2NO plus O2. Right, so now let's find the rate law for this. ROR is equal to K NO2, and it will be this exponent. Let's find the value of K, like the unit of K. So the unit of K will be ROR upon NO2, this. Now K is equal to basically ROR, being known as the unit would be mole dm cube second inverse upon here we have mole square and dm cube minus 6. So here we will get the value, which will be K is equal to mole minus 1. This minus 6 will go up and it will become plus 6. Then we will get dm cube plus 3 and second inverse. Right, this will be the value that we will get. this is basically the unit of K for this reaction. Now let's look into the some word problems of this. Right, but consider that we have a reaction which states that the rate of like we have a reaction which is, this is basically the formic acid. Basically when it combines with hydronium or ion, or you can say in the acidic medium, it will form HCOO negative plus H2O, right, in the acidic medium. The question is that what will be the rate of reaction when the concentration of formal acid is double. Like if the concentration of is double, if the concentration is double, then what will be the rate of reaction, right? So let's find out. Okay, here we don't know the concentration, so we will put X for this, and we don't need the product. We know that the value for this will be X mole per dm cube. Basically X shows the value of the formic acid, and mole per dm cube is the basically the unit of concentration, right? And H3O will be also X mole per dm cube, right? Let's find out the rate. Here R1 will be equal to K, concentration of HCOOH, and concentration of H3O, right? Now this will be equal to K. We know the concentration of HCOOH is X, and the concentration of hydronium is also X. So the rate 1 will be equal to Kx square, right? This is the rate 1. Now we want rate 2, right, when the concentration is double. Okay, it means on the doubling of concentration, like here HCOOH will be equal to now 2x, right? As we said that we will double the concentration. Now here R2 will be equal to 2x upon x. Now it will be equal to K2x square. Now this is basically the R2, right? Now we will compare these both equations. Now we will compare this, and it will be R1 divided by R2. Now it will be Kx square radical 2Kx square. So when we will divide, we will get the ratio 1:2. It means on doubling the concentration of formic acid, the rate of reaction will double. It will also double, right? And what if I will half the concentration of the formic acid? The rate of reaction will also become half. Why? Because as I said, the rate law states that the concentration of reactant is directly proportional to the rate of reaction. As the concentration will increase, if for example it gets double, the rate of reaction will also get double. If the concentration decreases, like it becomes half, so the rate of reaction will also become half, right? So I hope this word problem and the rate law is equal to you. If you have any kind of queries, you can ask me the question.